Hello scientists, and welcome to this video on batteries and electrochemical cells. Before you start watching, you need to get a copy of the notes from the box in class, and you need a pen or a pencil. So pause the video and go get those if you don't already have them. All right, let's go. So you're going to be copying the words that you see that are underlined and in blue. So remember from our last lesson that in static electricity, we use friction to separate the charges. So friction means we're rubbing two objects together and electrons are being transferred from one object to the other. Friction and batteries are two different ways of storing charges in an object. And a battery stores energy. The type of energy that's in a battery is called electrical potential energy. So the word potential, when we're talking about energy, means that it's stored. So you can have electrical energy that's flowing through a wire that's moving, or you can have electrical potential energy, which is stored energy in something like a battery. So an electrochemical cell is anything that transforms chemical energy, or the energy from chemical reactions, into electrical energy. So a AA battery is an example of an electrochemical cell. Even though we commonly call it a battery, it's technically an electrochemical cell. So there's a couple different types of cells. There's a dry cell, which is like this AA battery, where something called an electrolyte, which I'll explain in a minute, is called a paste. You can also have a wet cell, which is what's on the next slide. So an electrochemical cell transforms the energy from chemical reactions into electrical energy. On this slide, you see a diagram of a wet cell, and we're going to look at the different parts. These different parts are in both wet and dry cells. So the chemical reactions of two different metals or metal compounds occur on the surface of electrodes. So in this example, the electrodes are zinc and carbon. This is a carbon rod, this is a zinc rod, and the electrodes are in a solution called an electrolyte. So in this case, it is ammonium chloride. An electrolyte is a solution, which means there's an ionic compound dissolved in liquid. When something says it's an aqueous solution, it means that it's dissolved in water. Aqua means water. So you've got your solution here, and in it you have your negative electrode and a positive electrode. This yellow thing is a material that the ammonium chloride can pass through, and also electrons can pass through. And that is how our battery is going to work. So I'm going to explain a little bit more. So the chemical reactions that are happening in the electrolyte cause one of the electrodes to become positively charged and the other becomes negatively charged. So the positively charged electrode is called a cathode. The negatively charged electrode is called an anode. So I remember this has cat in it, cathode. I feel pretty positive about cats, so that's how I remember that positive is cathode. Might not work for you if you don't like cats. The negatively charged one, negative has an N at the beginning, and anode has an N in it. So that's how I remember that one. So the electrodes are also in contact with terminals. So here's a negative terminal and a positive terminal. When you've used a AA battery, you know that there's a negative end and a positive end. That's just what these terminals are. And when the terminals are connected to an electrical pathway like a wire, the electrons can flow from the negative terminal to the positive terminal. So here is a chart that compares a dry cell and a wet cell. So here is a dry cell. You have your electrolyte, which is a paste. The electrolyte can be ammonium chloride, which is what it is in this diagram. And then the anode and cathode look a little different here. So the cathode, the positive electrode, is a graphite rod. Graphite is a form of carbon. And then the zinc is actually this like purplish case around the paste. Okay, So that is the zinc, that anode, and the cathode is here in the middle, and that's why you get a little bump for the positive end. And then when you plug or when you put your battery in, there's going to be a wire touching the zinc case here in a dry cell. In a wet cell, it can be as simple as this. So you have some kind of container with the liquid electrolyte in it, and you have one metal electrode here and one little metal electrode here. So in a car battery, that's a wet cell. You have the anode, the negative one, is lead dioxide, so it's lead reacted with, or lead in a compound with oxygen, and then you have lead as the cathode, and it is in a solution of sulfuric acid. So car batteries can be quite dangerous to try to get rid of. So because of that, sulfuric acid and lead are both harmful materials for the environment and for you if you spill it. So if those are electrochemical cells, what's a battery? A battery is a connection of two or more electrochemical cells. So for example, you can put several electrochemical cells together to make a battery. So here, this battery is made up of 6 different electrochemical cells. Electrochemical cells and batteries are both called sources, and a source is anything that supplies electrical energy. We're going to use the word source a lot. So both electrochemical cells and batteries are sources. We measure the amount of charge, or the amount of electricity we can get from a battery or an electrochemical cell as the electrical potential difference. So this is a quantity that provides a measure of the electrical potential energy that a unit of charge gains when passing through a source. So either a battery or an electrochemical cell. This can also be referred to as the voltage. The symbol for electrical potential difference is a capital V, and the units are called volts, and the symbol for the unit is a capital V. This is named after Italian physicist Alessandro Volta, and he is credited as making the first battery. So that's why we call it voltage, after his last name, Volta. A typical AA or AAA cell provides an electrical potential difference or voltage of 1.5 volts. So why do we call this the electrical potential difference? We call it that because it measures the difference in electrical potential energy per unit of charge between the positive terminal and the negative terminal in an electrochemical cell. So, for example, in a 1.5 volt cell, it takes 1.5 units of chemical energy to separate the negative charges and the positive charges. So here on this AA battery, at your positive terminal or your cathode and the negative terminal or anode, it has the potential to give you 1.5 volts of electricity when you connect the positive and negative terminals. So I've got a diagram on the next slide that will help us understand. So this slide really tells us why this matters. So electrochemical cells or batteries are used to create a flow of electrons, and that's electricity. So when you have a conductive material like a metal wire, it can transport electrons from the negative terminal to the positive terminal. And this flow of electrons is electricity, and we can use electricity to do things we need, like turning on a light or running a heater. So here are at the negative terminal and on the negative electrode, a chemical reaction has happened in the electrolyte. That means that there's a lot of electrons available at the negative electrode, the anode. Okay, so there's an excess of electrons here. The same chemical reaction that caused a shortage of electrons over at the positive electrode. Okay, so there's lots of electrons here, and there's not that many electrons here. So there's a positive charge here. And you remember that opposite charges attract. So these negative electrons want to get back to the positively charged electrode. They can't get through this chemical, so when you connect it to something that conducts electricity, the electrons will move along it to get to the positive electrode. And now after a long time, you're going to start seeing these negative electrons over here at the cathode. Okay, they're going to have moved from here, so now we don't have these ones anymore. The battery dies when all of the electrons have moved along this wire to the cathode. I hope that was easy to understand. Have a look over your notes, make a star next to anything you want to ask me a question about, and I'll see you in class.